Welcome to the part 4 of this course. In this, we will be learning all the object-oriented programming features the C++ has. Object-oriented programming is a programming paradigm based on the concept of objects, which can contain data in the form of fields and the code in the form of procedures. What does this line means is that I will just tell you in a second. Second point is that OOP codes are reusable in the other programs. Third is that security is offered due to the use of data hiding and abstraction mechanism. And fourth point is that due to modularity and encapsulation, OOP offer ease of management. Let's have a look on the features of OOP. First is class, object, encapsulation, data abstraction, inheritance, polymorphism, dynamic binding, and message passing. Let's first understand what is a class. Class is a user-defined data type which holds its data members and member function, and those can be accessed and used by creating an instance of a class. Instance of a class is object. Everything in C++ is associated with classes and objects along with its attributes and methods. Objects are the autonomous entities of the class and they are also called as the instance of the class. Let's have a look at this program. Here class is flower. Private and public are the access specifier. Whatever we write in the private, the members cannot be accessed from outside the class. But in the public, the members can be accessed from outside the class also. In public, I have created function getData to get the name of a flower, to get the color, and then I am displaying that. In main function, I have created the instance of a class that's object. Now let's see the output of the program. Enter the name of the flower. For example, rose, color red, and it's giving us output rose and red. Okay. So I guess that you understood what is class and objects. Now next we will see about encapsulation. Encapsulation is an OOP concept which binds the data and its function together, and this keeps them safe from the outside interference and misuse. Let's see a real life example. In a company, there are different teams like account team, finance team, sales team, etc. The finance team handles all financial transactions, sales team handles all sales related things. There may be a situation an official from sales team needs some data from finance section. He cannot directly access the data of finance section. He has to contact an official from finance team and then request him to give that particular data. This is nothing but encapsulation. Let's have a look at the program. Here, A is made private. This variable can be accessed only using the functions set and show, and these functions are present in the class. The variable A and both functions are wrapped up together, and this is called encapsulation. Let's see the output of the program. Output is 15. I hope you understood what is encapsulation. Data abstraction in OOP is a process of providing only what is essential and hiding the internal details. Let's see an example. In AC, it has various functions like turn on or off, start swing mode, change the temperature, etc. But we don't know how does it works internally. Thus we can say AC separates the implementation details from external interface. Same is the data abstraction that is dependent on the separation of interface and implementation details of the program. Let's see a program to understand this more clear. Here, x and y cannot be directly accessed, but we can call the function set to enter values in x and y and the function to show to display the values of x and y. Let's see the output. 150 and 100 is our output. So I hope that you have understood the concept of data abstraction. Inheritance is the process by which an object acquires characteristics from one or more other objects. There are five types of inheritance. First is single inheritance. Let's have a look at the program. Here class birds, this is the base class. Then class budgies, this is derived class. Then there are function word play and in which it's outputting playing. In derived class, there is function chirp, which is outputting chirping. Main function, instance of a class that's object, and our output is playing and chirping. Next is multi-level inheritance. Class birds is our base class. Class budgies, this is our derived class. And baby budgies, this is derived from the budgies class. There are functions play, which is outputting playing. In derived class 1, there is a function called chirp, which is outputting chirping, and in the class baby budgies, that is derived from the budgies class, there is a function eat, which is outputting eating. Our output is playing, chirping, and eating. Next is the multiple inheritance. The syntax for the derived class is class name, visibility a-1, comma visibility a-2, and that goes up to an, and within the curly braces code of the block to be executed. Next is the hybrid inheritance. Here class A, this is the base class, code of the block to be executed. Class B, then public A, code of the block to be executed. Class C, class D, public B, comma public C, code of the block to be executed. This is the syntax for hybrid inheritance. Then is hierarchical inheritance. Syntax is class A, class B, access specifier A, code of block to be executed. Class C, access specifier, class A, class D, and access specifier A. Next is a polymorphism. Polymorphism means existing in many forms. Same entity like function operator is implemented in different ways. Polymorphism is implemented using virtual function, function overloading, and operator overloading. There are two types of the polymorphism, compile time polymorphism and runtime polymorphism. In compile time polymorphism, function to be invoked is known at the compile time, while in the runtime polymorphism, function to be invoked is known at the runtime. In compile time polymorphism, it is also called as overloading or early binding or static binding. And in the runtime polymorphism, it is also known as overriding, dynamic binding, and late binding. In compile time polymorphism, it provides fast execution as it is known at compile time. In the runtime polymorphism, it provides slow execution as it is known at the runtime. In compile time polymorphism, it is achieved by the function overloading and operator overloading. In runtime polymorphism, it is achieved by the concept of virtual functions and pointers. Next is the dynamic binding. In dynamic binding, the code to be executed with response to the function call is decided at the runtime, and to implement this concept, the virtual functions are used. Let's see the program. Class A in this function with the return type void, then virtual function return type void show cout base class. Class B inherited public A, virtual function return type void, function name show cout derived class, main function, objects. Here our output is base class, then derived class. Message passing. Message for an object is nothing but the request to execute the procedure which will invoke a function in the receiving object that generates the desired results. In message passing, we specify the object name, function name, and the information. Object communicates with one another through sending and receiving information with each other. Friend function or friend class have full access to the public, protected, and private members of any class. Friend class. We can also declare a whole class to be a friend of another class, and this allows all the member function of the friend class to have the full access to all the members of other class. Friend function. We can make the functions friendly to the classes, and this allows the function to have the access to the private data. Note: also, this function need not to be a member function of the class, and if the two classes are not related with one another, that is, there is no inheritance between one another, then friend function act as a bridge between them. To better understand the concept, let's see an example. In the friend function, I have created a class A. In private access specifier, there is a data with the integer data type, then integer show data, integer is the return type, and this function is friend to the class A. Integer show data, this is the call to a function, then main function, and this is the object of the class A. This function is declared as a friend to the class A, and therefore it can access the private data of that class. Output of this program is data equals 100. Now same concept is used in the friend class. Instead of declaring a function as a friend, here whole class is declared as a friend. In this, our output is also data equals 100. The last concept of our part 4 is constructor. The initialization of object is done by a special function called as constructor. Constructors are implicitly called whenever we define object of their classes. Name of the constructor is same as the class name, but without the return type and nor even the void. The syntax for default constructor is class name, body of default constructor. Syntax for parameterized constructor is class name inside parentheses, parameter list, and the body of parameterized constructor. To better understand the concept, let's see a program. Here, class name is A, integer data. In public specifier, this is the default constructor. The name of the constructor is same as that of the class name, therefore A. In that, cout default constructor. Next is the parameterized constructor. In that, cout parameterized constructor, data equals A and cout the data. The default constructor is invoked when the objects of the classes is created. Second is the parameterized constructor with the parameter 100, which is called in the body of which we initialize the data member defined in the class. So that's all in the part 4. We have completed with our course. I hope you have enjoyed this course. In future, I will definitely add more video tutorials in this course. If you like my app, then don't forget to review the app and share with your friends.